All right, 2.5, main part of 2.5 that we'll deal with today is going to be with the rational zero theorem and then fundamental theorem of algebra. So whenever we use rational zero theorem, if you don't have a graphing calculator, could be a long process. Basically, it tells you all of the possible zeros that you can have of any sort of rational or polynomial, okay, or polynomial function. So whenever we do this, basically what we're going to do is we're going to take all the possible rational zeros. To find that, we need to find the factors of the first term, or the constant term, and then we're going to divide it by all the factors of the leading coefficient. So whenever I do this, if I have my P over Q, okay, so if I'm going to go P over Q, now what I usually do is whenever I add to my list, so if it's P over Q, P is all the factors of the constant term. So whenever we write this, it's like P divided by Q. So what are all of my factors of 4? A, plus or minus 1, plus or minus 2, plus or minus 4. Okay, we have to include the plus and the minus because I can go -4 times -1 and still get a positive 4. Okay. Because if we have rational zeros, basically you can have zeros that land on the negative side with the x value, with the x-intercept, or the positive side on the right side. It's not just going to be one of those that's only going to be on the right or it's only going to be on the left. Okay. Now, the way that I do it is probably a little bit different than some because, again, I like to work smart, not hard. I usually don't list out the values of Q. I usually just take whatever I have and just start dividing by that, or just kind of adding to my list. So in this case, if I have a -1, the only options here that I have are plus or minus 1. You're always going to have a plus or minus 1 in any sort of your Q list or of your lead coefficient. Okay? That is a given. Now, as far as like my possible zeros are concerned, usually what I would do is basically just take the list that I have because every one is divisible by 1. So that means everything that's in the box is going to be divided by everything that's in the circle. So since I always will have 1, I'm basically just going to take the list that I have with P and I'm going to add to it. So is there anything that I can add to this list in this case? Is there anything else that I'm going to divide by besides the plus or minus 1? No. So my possible zeros are basically just these 6, okay? Not just 3, but there are 6 values that are my possible zeros. I have no issue in you, if you want to rewrite it and say, well, it's plus or minus 1, it's plus or minus 2, and it's plus or minus 4. Okay? There are my possible zeros. It's when we have numbers like on 2 that your list is going to get really large. So if I have all of my possible zeros on 2, the first thing I'm going to do is, so my P values, okay, so all of my factors of -3. Well, that's a pretty short list. Plus or minus 1, plus or minus 3. All of my values of Q, so I have to look at my lead coefficient. So I have a positive 4, so just like it was before, plus or minus 1, plus or minus 2, plus or minus 4. So in terms of my list, I know that all of my p-values are automatically in my list, because if I divide every single one by 1, it's just going to be that value, right? What I need to do next is then take each green value and divide it by each purple value. So if I'm going to add to my list as far as the plus or minus 1, I'm not going to rewrite the list usually. I'm just going to tack on whatever else I have. So I'm going to have plus or minus 1/2. I'm going to have plus or minus 3/2. So what did I do? I took the 1, divided it by 2. I took the 3 and divided it by 2. Okay, so that one was taken care of. Do the same thing again, but now do it with the 4. So plus or minus 1/4 plus or minus 3/4. So in terms of all of my possible zeros, it's the original list that I have here, and then those values that I basically added to or tacked on to my original list as far as my p-values. Okay, as far as all my factors of my constant value. Okay, so how does this fit in? Well, about 400 years ago, some old white dude came up with how we're going to basically graph this. Okay, as Mr. Kaiser says. So, or how many rational zeros we can have with any of these. So, whenever we do this, now we're going to basically find a better way, or I'm going to show you a better way, but it's going to basically narrow everything down. So the first thing I want to do is figure out what are my possible zeros. So in this case, I'm going to take the -6. What are all of my factors of -6? Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Is there anything else I'm going to add to this? To this list, because there's a 1 out in front, right? If I just do it, there's nothing out here. So my Q, okay, if I would actually list this, now again, I don't usually list it, okay, I usually don't put my Q, okay, because plus or minus 1 and that's it. I just kind of go from there. So of my possible zeros, it's really just the numbers that are here in red. So it says to use trial and error with synthetic division to find the first factor x minus c. Okay. Now it does have another little note up here. Okay. Use a graphing calculator. You've got 4 different values. Okay. Whenever you figure in one's positive and one's negative, that's 8 different values. Do you want to try 8 different things to see where it's going to cross the x-axis? Heck no. So, what do you have to do? Well, you've got to go to your graphing calculator, and let's make this a heck of a lot easier for ourselves. So whenever we do that, all we're going to do, we're going to just basically type it in. We know that we have 1, 2, 3, and 6, positive and negative. So whenever we do this, we go to our graphing calculator, and we go to y equals, clear out whatever we had. We have x to the third plus 2x squared minus 5x minus 6. So plus 2x squared minus 5x minus 6. Did I type it in right? I believe so. Let's make sure everything's typed in correctly. I'm good. So go to graph. I would make sure it's in a standard window. You know that the farthest it's going to go is going to be from -6 to +6. Right? So then, as far as my values, it's all rational zeros. So then, just by looking at it, which values should I probably try to use synthetic division? What are my possible zeros that are most likely the case? Well, -2, or is it -3, -1, and +2? Those are gonna be the first ones that I try. Okay. What should happen is if I use those values, so -3, -1, and a +2. Okay. All I'm gonna do is go back here. Okay. And I'm gonna use synthetic division. Now I would use it. Okay. I'm not going to stop. So if I have, so of my values, remember we had ±1, ±2, ±3, and ±6. The values that I want to try were what? -3, -1, and +2. It does not matter to me which one you try first. Okay, so all I'm going to do, if I have x to the third, I have x squared, I have x, and I have my constant. So I'm going to go 1, 2, -5, and -6. It does not matter to me which value you start with. I'm just going to start with the first one. I'm going to start with -3. I'm going to drop the 1. -3 times 1 is going to be -3. Straight down is going to give me a -1. -3 times -1 is going to give me a +3. Oop, straight down gives me a -2. -3, -2 gives me a +6. I end up with a 0. This is a good thing. Now, you may have people, so -3 is a 0. That's good. Okay. Do it again. Now, I do it a little bit different. I just keep going. Okay, I just basically keep going and do this right here. Now, I can't pick a -3 again. I need to pick one of the other two values. Okay, I'm just going to go down my list and I'm going to pick -1. I'm going to drop the 1. So, -1 and 1 is -1. -1 and -1 is -2. -1 and -2 is a +2. Straight down. Look at that. Another 0. That's a good thing. So, -1 works. I'm just going to keep going. Keep doing synthetic. It just gets shorter and shorter every single time. So now I'm going to use a +2. So I'm going to drop the 1. 2 times 1 is 2. What do you know? It's 0 again. That's a good thing. Since I know I can kind of look to see where does it cross the x-axis, those are automatically going to be the first ones I'm going to try. Okay? So even like 4, and I would say, like if I have x to the third, what number is that? 4? So like on 4, if I have x to the third plus 7x squared plus 11x, so x to the third plus 7x squared plus 11x minus 3. Minus 3. So just by looking at it, okay. Now, it crosses at 3 places, right? Of my rational zeros that I have, though, okay, if I would list everything out, the only... What's the only one that I'm probably going to be able to try? Like if I had all of those values, okay, if I go back to right here, okay, and like the only options that I have here for P are plus or minus 1 and plus or minus 3. Q is not going to add anything to my list because I'm just going to divide it by 1. So the only options I have are positive 1, negative 1, positive 3, and negative 3. Which of those, if I go back to my graph, okay, if I go back to my graph, now if I don't have a graphing calculator, then I'm just going to have to try every single point. Which point do I want to try here? Which one of positive 1, negative 1, positive 3, or negative 3, which one do I want to plug in to find a 0? Negative 3, right? Because it's right here. The other two are kind of in no man's land as far as where we're looking. Okay, so that's going to give us kind of a little bit of a hint as far as what we have to do. So if I have negative 3, okay, so the only option that I have in this case is negative 3, and I still have to find all the zeros. So I'm still going to have a 1, I'm still going to have a 7, I'm going to have an 11, and a negative 3. So I'm going to try negative 3. Now, knowing that I looked at everything, I know that it's going to cross at 2 other places. The problem is they're not rational values. So whenever I drop the 1, negative 3 times 1 is going to be negative 3. That's going to give me a positive 4. Negative 3 and positive 4 is going to give me a negative 12. So negative 1 is going to give me a positive 3, and I'm at a 0. The problem with this one is, or not really the problem, what makes it not so nice and neat and easy is that I can't just keep doing synthetic division. Okay? I can't keep doing synthetic division. Here's my remainder. Here's my constant. There's x squared. So I have x squared plus 4x minus 1. I still have to solve for this and figure out, like, if I set it equal to 0, okay, I can't factor it. I can't do synthetic division. So how do you want to go about solving this one? What formula can we always use? Quadratic. So A is 1, B is 4, C is negative 1. Realistically, you're going to go to, for most of you, are going to go to your graphing calculator instead of doing it the long way. And you're going to just type in quad 4. And you're going to have this a lot faster than I am. Maybe not. Maybe you don't have the program. By now, I'd be really surprised. Divided by 2. So I have negative 4 plus or minus 16 plus 4. So the square root of 20 all over 2. Negative 4 plus or minus 2 square root of 5 all over 2. That's a 2, that's a 1, that's a 1. So my other answer is at negative 2 plus or minus the square root of 5. So we have our three zeros. We have the negative 2 plus square root of 5. We have negative 2 minus the square root of 5. And then we have the nice neat answer up here with the negative 3. Okay?